All right. Ooh, cool. Cool. Hi, everyone. I'm Soroush. And today I'm going to be telling you why you deserve nice things. So our story starts with a simple method in Foundation. This is contained string. It tells you whether one string is completely contained within another string. And it's a very common usage. And every standard library really should include something like this. But what I find particularly weird is that this was added in iOS 8, which is surprising because if this is something that every standard library needs, why was it added so late? This was like 3 years ago. And a string has been around for something like 20 years, and it hasn't been added until then. So what did we use before then? Well, we used this other method. It's called range of string. And you search for a string, and it returns a range. A range has a location and a length. And the way that you would use it to check for containment is you would write some code like this. You have a haystack, and you're looking for a needle. So you would search, haystack, range of string, needle, dot, location is not equal to not found. Now, I don't know about you, but I think this code is terrible. It's impossible to read. There's like a double negative, so it's not equal to not found, which I think is really tough to parse. And when I asked one of my friends, like, why does Apple make us write code like this? Like, it could be nicer. It could be so much easier if we had a method like contain string. And he responded, he's deleted this tweet since, and I don't want to say his name, but he said that the Cocoa team tried to avoid adding API that might save a few lines of repeated code if it didn't add useful abstraction. And I think this approach is wrong, and what I'm going to go over today kind of, I hope, can convince you that, that this approach is essentially wrong. So if you wanted to add this thing yourself and add your own abstraction for it, you could really easily do that. This is a category in Objective-C. It's called an extension in Swift, and you can define a new method on an existing type, and you can kind of encapsulate that code that we had before, and hide it away so that you don't have to look at it. And that works to some degree. I think it still has a couple problems, which we'll touch on later in terms of the vendor's responsibility for maintaining these abstractions for us. Yeah, so eventually they did add this method, so we don't need to add our own extension anymore. One of the reasons I don't think it's enough to add our own extensions is if you go to GitHub and you search for range of string, just the name of the method, and you limit your search to Objective-C, you'll find tons of examples just using range of string to just to figure out, like, does this string contain this other string? So you can see this first one, range of string mayo.length is greater than 0. This one, range of string of the question mark is .length is greater than 0. These are doing the exact same thing. And so people weren't using the advanced features of range of string. They're just using it for containment. So I think it makes a lot of sense. They added this. They added in iOS 8. It's now also in Swift, which is great. So we talked about Foundation a little bit, but the Swift standard library also suffers from this problem. So this is another example. This is Swift 2 code. This was like the first extension that I would add to any new project that I was on. It essentially, it's a function. You give it a predicate. A predicate is a function that goes from an element to a Boolean. And what it does, it finds the first element in that sequence that passes that test. And I would use this all the time, and I was really happy to learn that they added it in Swift 3. So when they added it in Swift 3, it looks something like this. They also added throws and rethrows, which I didn't have in my implementation. It's even nicer to use. And I bring up these two examples because it shows that the way that Apple has structured the code today is not necessarily the way that it has to be forever. It's not like that for any reason other than that's just where they decided to draw the line. And so we can change those things. And I think like adding extensions and showing the usefulness of these different abstractions is one way to kind of get to that beautiful end state where we can all write better code. And so to that end, what I'm going to present today is a few rules for when I think it's useful to add an extension and when I think it's basically not as good of an idea. So the first of these rules, I think is the most important, which is, does it increase expressivity? So does it make it so you're expressing more ideas with fewer characters of code? So let's take a look at an example. This is a little bit of code. We basically create an array, and the array is just the numbers 1, 2, 3, 4. And we want the pairs. We want the individual pairs. So we want a new array where the first element is the pair of 1 and 2. The second element is the pair of 2 and 3. And the third element is the pair of 3 and 4. Now, you can do this in this just with code in the Swift standard library. It's a one-liner. It's very short. You zip the array with the array minus the first element. And this does work. This gives you exactly what you want. But ultimately, this code is hard to read. When you look at this, you don't think, oh, this is going to generate pairs. You think, well, this is going to generate a zip of something and another thing, which is originally based on the first thing. And eventually, once you start seeing it a few times, you start to realize, oh, I've seen this before. This is the code that generates the pairs. And so what you end up doing is you end up building an alias inside of your head that represents the fact that this weird structure, the zipping and the drop first, is actually something that generates pairs. So instead of creating an alias in your head, you can just create the alias in the code. And so in this extension on sequence, you essentially have a function that returns a new sequence of pairs and kind of encapsulates that sort of zip and that drop first for you, and you never have to think about it again. And so when you go to use it, you can just use it in line like you'd use anything else. And one super nice thing here is that you've actually defined it in such a way that it can be used in chains. So you could do a map, and then you could do a filter, and then you could get the pairs, and then you could map again, and then you could do maybe a for each at the end of that. And so that's really a new capability that you didn't really have before. Before, you'd have to assign it to a variable and then use that variable in the zip, and it was just ugly. But now it's a little bit nicer. And as we all know, you deserve nice things. Another example of increasing expressivity is this right here. And we've seen this code a lot, this reduce 0 and plus sign. And we've seen it so much that we know what it means now. We know this means, oh, this is going to sum up all the elements in a sequence. But that's not what the code really says. The code really says I'm going to reduce all the elements into the sequence into the value 0 using the plus operator, which adds things, which is not really the same thing as sum. And especially for beginners, this can be really hard to read to understand what exactly this is doing. So we can define these extensions on signed integer and binary floating point, which are two protocols in Swift which encapsulate almost all of the numeric types. And then we get a really nice, well-typed message that represents exactly what we're trying to do and says what we're trying to do. If someone comes along and reads this code later, it says .sum, and we know what sum means. This also works for averaging, which is really cool. And it's totally abstract, so it works with any float, any double, any CG float, I think it might even work with, I guess it wouldn't work with NS decimal number, but it could work with any other floating point number, which is really great. And in Objective-C, we would write code like this, but we would use key value coding. So you'd do @sum as a string. And now we can do sort of the same thing, but it's type safe. So it only works on elements or on sequences where the elements are numbers, and the compile time system will check that for us. So that's the first rule, is are we increasing the expressivity of our code when we add this extension? Rule number 2 is very similar to rule number 1, but it's slightly different, and I'll go over how that is. So rule number 2 is, does it decrease noise? And I think a really great example of that is this code. I think everybody's done this. You have some integer, and you have some CG float, and you want to multiply them together. So obviously, you use the multiplication operator, and immediately you get hit with a compile warning. And it says, binary operator star cannot be applied to operands of type CG float and int. And it's just saying, hey, these are two different types. You can't multiply these two types. I don't know how to do that. So you have to fix this. So everybody knows how to fix it. You wrap the ints in a CG float, and then now you can freely multiply them together, and your result will be a CG float as well. The CG float in here, however, is completely extraneous. Anybody reading this code doesn't care that you have to convert the int to a CG float before you can use it. All they care about is what's the main thing that we're doing here. And the main thing that we're doing here is this tiny little character. And adding this CG float just confuses the actual purpose of this line, which is to multiply two numbers together. And so, because you deserve nice things, we can add extra overloads for the operators for the operator for star, one that multiplies ints and CG floats, and one that multiplies CG floats and ints. And then when we go to write our code, it works exactly as expected, no compile warnings. Adding custom operators in Swift can be a little bit dangerous sometimes because different libraries might bring the same operator. They might do things where the name does, or where the operator itself doesn't really express the meaning that, of what is actually happening. And there are situations where the same operator might want to do several different things. But I don't think any of those things apply here because the star operator is very well understood to be multiplication. There's really only one way to perform this multiplication and keep all the specificity of data. So I think it's actually an OK time to add an operator and say, you know what, I don't want to see that CG float conversion. All I want to do is multiply these numbers. Why don't you let me multiply these numbers? Another example of noise is this function that I like a lot. So this function returns true when all of the elements in the sequence pass this test that you pass it. So if you want to write that with just a standard library, you have to put this exclamation point before it. You can use contains where, and then you have to put this exclamation point inside the body of the predicate as well. And so this is really saying, does this sequence contain any numbers where the test is greater than 0 is not true, but also not the whole thing, which is impossible to read. And when you see this in the code, you might even miss this tiny little character, and you might be misunderstanding exactly what it does. You might be tempted to add a comment to explain what this does. But you don't have to do that. You can add an extension that lets you describe what it is exactly that you're doing. And in the nice form of this, you just say, hey, in this sequence, are all the elements greater than 0? And the answer is, of course, false. It's easy to read, and it's easy to evaluate the expression in our own heads. Another counterpart to this all function is the none function. Do none of the elements in this sequence pass this test? And that's similar here, but except there's now a not missing here, but this not is still there. And again, still pretty hard to read. Does it contain any values where it does not pass the test greater than 0? Down here, much easier to read, similar type of thing. And then to round out the trio, there's any. Any is actually just exactly the same as contains. But I usually, when I add the first two, I add the third one too, just to make it all balanced. These names aren't necessarily the only names you can use. I stole these from enumerable in Ruby. But I think if they were in the standard library, all would probably be called like contains only. This would be called contains none. And then this one could be called contains. So that's rule number 2. We're trying to decrease noise wherever possible. Rule number 3, you don't always have to pass this rule, but it is nice when you can. And the question is there an optimization in your extension that you can apply once and get the benefits everywhere across your code base? So let's take a look at an example. This is some code. I actually think this one's pretty easy to read. How many elements in this array are greater than 0? And this one's not so bad to read, but if you'll notice, this filter actually generates an intermediate array. And then we call count on that array and then throw the array away entirely. And this is not exactly the most performant thing. Probably it's OK. There's only 6 elements here, not a big deal. But over the long term, maybe there's a situation where you do want that to be very well optimized. You can make a function called countWhere. And instead of keeping track of an intermediate array, it just keeps track of an intermediate integer. And then it returns that integer. And at the end, you end up with this code, which in addition to being a little more performant, also looks nicer. So you deserve nice things. This function is called countWhere, and it will tell you how many objects in a sequence pass a test. Another example of a hidden optimization is, we'll take this Objective-C code. There's 3 elements in this array, the strings A, B, and C. And we write some code, and we expect, oh, it might be called reversed array. Let's just type reversed array and see what happens. And of course, it says, no visible interface for NS array declares the selector reversed array, which sucks. So we replace that code with array.reversedObjectEnumerator.allObjects, which is a mouthful, but it works. But one of the things this code does is this code actually creates a full copy of that array. So it'll take the first array, and then it will make a copy where the last item is moved to the beginning, and the second to last item is moved to the second element. And it moves all these items when you create this array. And so this way is a little bit slower. You have to create this whole new array, and you have to create all this extra stuff. And it turns out, this is a really fun fact, if you actually pause the debugger on this line of code where you create this array, and you go into the debugger and you type PO array reversed array, it actually totally works. It returns a special class called an __ns array reversed. And you can imagine what this does is this holds on to the original array, and every time you ask for the 0th element, it gives you the count -1 element. Every time you ask for the first element, it gives you the count -2, and so on. So it never creates a copy of the array. All it does is just reference the original array, which I think is pretty cool. For some reason, this exists in your Objective-C runtime, but you don't have the header exposed to be able to take advantage of it. So if you were to write this code sort of the naive way, you would write it where it creates a full copy. But if you were to create an extension, you could write this code once that generates this more optimized version, and you could use it as many times as you want. Now, Foundation makes the mistake of not exposing this, but the Swift standard library does expose it, which I think is nice. And so if you call reversed on a random access collection, you will get a special reversed random access collection. And that collection will perform the same optimization where it doesn't actually copy the collection. It actually references the original one. And every time you ask for an element, it does the conversion and figures out the right thing to give you, which I think is pretty cool. So that's the third rule that I really like. Is there an optimization? You don't have to have an optimization to make an extension worth it, but if you do have an optimization, I think that's a clear sign that that's something good to do. And the last rule is, does it belong on every instance of this type? So I'm going to give you an example here. Imagine you have a dictionary, and that dictionary has a bunch of properties. It's a string any dictionary. And it has maybe like a URL. It has a method, it has some parameters, a request timeout, and all those properties are in that dictionary. You could really, theoretically, you could add an extension to dictionary where it would be able to build a request from the properties in that dictionary. And I don't think this is a very good idea because there are other dictionaries out there that don't have any of these properties. They have nothing to do with building requests. And so this is not a useful thing for most dictionaries, and so I think this extension is not a good idea. Instead, maybe what you would do is you would create some kind of builder, like a request builder, and then wrap the original dictionary, and then put your code to generate that request on that sort of wrapper. And you might say, Soroush, this is a really contrived example. Nobody would ever do this. You're crazy. But I have actually seen code, a real project that's in the App Store that does code like this. This is an extension on NS Dictionary. It's in the push notification namespace because it's for push notifications. And what it does is it basically gets the object of the key APS, and it returns it as an NS Dictionary. So it's not like this is doing nothing. It's doing two important things. It's digging something out of the dictionary, and it's casting it as another dictionary. That's actually useful work, but there are lots of NS dictionaries in our system, and most of them are not going to have this APS key. So what is this doing here? So that's the last rule, is does it belong on every instance of this type? Those are the basic rules. I want to go over a couple of interesting, useful things that, that exist elsewhere. I have a lot more of these, but I only have 25 minutes. Here's a good one that I like. This is uniquing. If you want to unique something in Swift and you want to use just a standard library, the recommendation would be, well, take all your elements in your sequence and wrap it in a set, and then take your set and wrap it in an array, and then that's unique elements. Great. But that doesn't preserve order. And so I have no way of knowing if the original order of the array is going to be maintained in the resulting array. And so that's what this method does. It basically has a result that's empty, and then it loops through the original sequence, checks whether the element is already in the sequence using some elements equal function that you pass it, and then if so, it'll append to the result. And then there's also a little helper. If the element is already equatable, you can just use the equal, which is really nice. And I use this in my code today, but if you wanted to write it with just Foundation or just a standard library Swift code, you would end up with something that doesn't give you exactly the results that you want. So I think this is a particularly useful one. Another one that I think is really useful is when we have sorting. Here's a really common example. I think everybody's written code like this. You have a bunch of houses, and you want to sort the houses by the number of residents that they have. And this will give you an array where the house with the least number of residents is first, and the house with the most number of residents is at the end. But if you look, there's a very, very small amount of duplication here. We're calling $0 dot number of residents, and we're calling, oh, that should be $1, my bad. And then you're calling $1 dot number of residents. This is a bug, and it wouldn't have existed if I used the extension that I'm about to show you. So there's a bug here, but you're calling this property twice. And so why would we do that? Most of the time when we want to sort something, we want to sort it based on one property. So we can do that. We can make a special extension. We're going to give it a function that I call a property accessor. And it's going to give us our original iterator.element, and we're going to return some t. And the only rule is that the t has to be comparable. And since that t is comparable, we can actually call the property accessor on $0 and on $1, and then compare them with the operator. And then we get this really beautiful code at the end. Instead of sorting by this function, we're sorting on this property. And there is actually, for bonus points, there's actually an optimization that you can do if you use this method instead of this. If you use this, there's a small optimization you can do, and it's like bonus extra credit if anybody wants to figure it out and come talk to me at the party later tonight. Think about how many times we're calling this property accessor and see if you can figure out what the optimization is. So I think this one is super useful, and it makes really, I think, really pleasant code that doesn't have bugs in it. Cool. And then we've mostly been talking about the Swift Standard Library, and we've been talking about Foundation, but the problem exists in other libraries as well. UIKit is a big one. This is a common example. Sometimes you want to get the aspect ratio, but you can't remember if you're supposed to do width over height or height over width. Like, you should never have to think about this. You deserve nice things. It's always height over width, and you just call aspect ratio, and you always get the right thing. So this is a really common one. Another one that I really like is UI gesture recognizer has no way to cancel it. And if you go on Stack Overflow, you can find out, well, actually, if you set is enabled to false and then set is enabled to true, that will actually cancel the gesture recognizer, which is really nice, but I didn't know that. And this doesn't exist on there, so I can't just type .cancel and see what autocomplete gives me. So if you were writing code normally, you might just, in your view controller, you'd write, my gesture recognizer is enabled false, my view controller gesture recognizer is enabled true. And then somebody would come along later and be like, well, why are you setting it to false and then setting it to true? That makes no sense. So then you add a comment that says, OK, really the reason we're doing this is to cancel it because we want to make sure it doesn't interfere with this other gesture recognizer. But you don't have to do that. You deserve nice things. Make a function called cancel. Then you don't need a comment. You don't need anything. And just call my gesture recognizer.cancel, and you're done. The last one I want to touch on is on UI view controller. I don't know why this doesn't exist. I always wonder, hey, how can I tell if the UI view controller is on screen or not? And the trick is you just check if the views window is not nil. But if you don't want to load the view, if it's not already loaded, you can check is view loaded. So this is another little optimization. And then if you just add this, then you can just check view controller that is visible. You deserve nice things. So that's my talk. Thank you, everyone, for your attention.
Thank you.
All right.
Thank you, Soroush.
Cool.
I really want those nice things. Who's going to provide them to me?
That's a good question. I think it's Apple's responsibility to provide them for us. I'm sorry.
Yeah, no. That's a big question that I'm not completely sure about that because there are different approaches. Like as you were saying, like the Ruby approach is really like you provide everything, functions to do anything in any way. But sometimes it's probably not really easy to maintain that and to make sure that the code is not like really funny at the end.
Yep.
So I'm not completely convinced that it's the role of Apple, and maybe it's more the community stuff to do.
Yeah. So I think there's essentially three options here. Option number one is I just add these all myself. Option number two is I put everything into a big CocoaPod, and somebody can just import that CocoaPod and then use it. And option number three is Apple provides it for us.
But you mean put that in a CocoaPod at enterprise level, like your company would do that? And
that's the big question. So do you think these are useful? Yeah,
Sure.
he likes it.
No, but
Yeah, they're useful, right? Have you ever imported a CocoaPod to add this stuff? Because there are CocoaPods that exist that do
Yeah,
that.
actually, yes, but I don't want to end at the. I mean, to finish my project and having like 80 CocoaPods installed in my.
So you could have one
Pod
CocoaPod
file.
that has all of them. Have you ever used one of those? Like they had
Oh.
Objective Sugar back in the day.
No, the
Yeah, I mean,
Yeah, but-
I tried not to actually.
Yeah, exactly.
usually I kind of like some of them, and some others I really disagree. So
Yeah.
like that's
That's
really
the
a
problem.
strong.
So
Yeah.
BlocksKit had this problem.
Exactly,
Objective
yeah.
Sugar has this problem. And there's a bunch of Swift ones. There's like the $sign library
Yeah.
that turned into the emoji $sign library.
Just like jQuery for
Yeah,
iOS.
jQuery.
Right?
Yep, exactly. Or underscore or whatever, low dash.
Yeah.
But the problem is that we trust Apple to do a good job with these. We don't necessarily trust anyone in the community to just give us everything.
Yeah,
And
that's
so
true.
I think for that reason, and I've actually tried this. I made a library called Objective Shorthand. And the point of it was to provide map and filter and a bunch of other really useful things, uniquing, reversing, all that stuff to the users of the library. But like nobody cared, nobody wanted it because, and that was fine. Like I used it where I wanted to use it, but nobody really cared. So I think it's ultimately has to be the responsibility of Apple.
Yeah, and it's a problem also of how people will discover your framework. and
Exactly.
that's really
Yeah.
a complex problem.
It
And
definitely is.
there's a lot actually. There are many,
Yeah,
many
there are
of
many.
those.
Yeah,
How
there's
to
hundreds.
choose
I've seen tons.
Yeah.
And everyone is going to kind of differ from your taste a little bit. So what I've taken to doing is I just have all these in gists. And so on GitHub, I just have tons and tons of gists. And when I made this presentation, I just went back through my gists and found all the cool ones and put them in the slides.
Question that somebody asked already. So are they just public actually? So can people in the audience just grab your gist with the?
Yeah, I don't have a good solution for that yet. One quick thing. Are we here?
Yeah.
Yeah, it's supposed to be to stay here actually.
No,
So,
Michel,
my friend-
Jean-Mi en régie est réactif. Is reactive, so.
This is my friend Just Dave, and he runs a Twitter account called Public Extension, and he doesn't post anymore, which is sad. But
He got killed by Apple.
He got killed by Apple. You know, they got him. But yeah, so he basically had this thing where every day, every week, whatever it was, he would post a new one, and there are lots of really good ideas there. I'm not really sure what the best way is to put all these things out there. I think Just Dave's Twitter account was really good. I don't really know what the best way to get them all out there. I can put them all in a big GitHub repo, but then somebody's going to ask for a CocoaPod, and I don't want to
And
support
to
that.
maintain and to fix bugs and
Yeah,
to
exactly.
like,
Maybe a blog post,
did you
I don't
test
know.
that and
Exactly,
things like
yeah.
that? Yeah.
And some
But-
of them, yeah, I have tests that I've written for him, and then, because like when I write any, all, and none, like sometimes I'll just write it instead of copying it. And I'm like, well, did I get the knots right? Did I get the exclamation point
Exactly.
right? Let me go write some tests, and then I have the tests, and then it's like, it's crazy.
That's actually that. I mean, when you talk about Apple, they are, in my opinion, adding a lot of new functions to the core foundation. For example, if you look at dates or at strings, there are much more things that previously, as you were saying at the beginning. And about testing and like, if we go to the safety of the code, it's true that having some code that is already tested and that even though it's a few lines, then it's much safer. But in terms of safety, I think.
Yeah, but yeah, of course, it's, I guess a drawback on that is that you have like less noise, of course, but maybe less visual correctness. I know the code looks like less visually safe in a way. So I'm like adding CG floats to floats. That's perfectly fine for my business logic, but maybe from a mathematical point of view, it does maybe make less sense.
Yeah, you can see the business logic, but it kind of hides some kind of maybe corner cases or stuff like that. So that's all.
I mean, I think that's kind of true of any abstraction that you do. You're obviously not going to put every single thing in one big function. You are going to abstract to some degree, and part of those abstractions is they're going to leak a little bit. The examples that I tried to give on stage here, I tried to pick ones that don't leak much at all. I don't think if you're multiplying an int and a CG float, usually you don't want to convert the CG float to an int. Almost never.
And if you want to do that,
and if you want to do it, you can do it manually.
Yeah, and you will have a special policy for that. So that's going to be part of your business logic, maybe.
Yeah, for sure. Or you can convert it at the end, or you can just not use this one. And yeah. So you have options.
So let's assume you have like lots of those helpers, and so you want to make them discoverable for your team. Let's assume you have like 10 people working on the same app.
Yeah.
How, or even more, how you make them discoverable?
So I saw this really great talk at a conference. It was by a fellow named Igor. And he suggested that you can use code review to find stuff like that. So that's a great place is usually when there's code review. Sometimes I'll see code that's like filtered.count. And I'm like, actually, you can use count where here, and it's much easier to read and a little bit more performant.
Yeah.
So code review is a great place. Autocomplete, just the fact that it exists is pretty good. And as your project does more and more of these things, everybody on the team gets more used to all the different things that are available.
Awesome.
I also really like the idea that you had to look at the GitHub code and try to check how people are using those functions. And that's really interesting to see that there are functions that are actually only used that way for this other functionality. And that was really interesting. Have you found other funny things with that?
That is one of the most interesting functions because if you look at range of string, there's a lot of different forms. Yeah. There's options, there's NS regular expressions you can do. You can do crazy stuff with range of string, but nobody does.
Yeah.
Nobody ever does that. And so that's such a perfect example because you look at it and everything is just containment. It's all containment.
Yeah, and that kind of function have been created like 20 years ago for macOS development, which probably at the time quite different from what we are doing today.
Yeah.
That's nice to have a new language, by the way.
Yeah.
So, guess that's all for questions for today.
Cool. Yeah, thank you very much
for the talk.
The talk.
My pleasure.
It was really inspiring.
Thank you so much for having me.
Our pleasure.